Hello everyone, my name is Kirill. I love metalworking, engineering and making interesting things. I also love the combustion engines. So I decided to design and build my own 4-stroke microengine. And I'm planning a video series about building and testing it. In my last video I built a micro turbocharger. You can check out that process, link in the video description. And in this video we are going to run a few tests with the turbocharger and see if it actually works. A turbocharger this small needs to spin very fast to create any meaningful boost. By my calculations, the maximum speed should reach around 2,500,000 RPM. And I wanted to be able to measure that. But there is a problem. I couldn't find a tachometer that measures speeds this high. So I built one myself. Calculating the turbine nozzle geometry is pretty complex, so I made it adjustable. I can set the nozzle gap anywhere from 0 to about 1 mm. This lets me control the exhaust gas speed at the nozzle, so I can try to reach maximum turbine speed without choking the engine too much. Time for the first test. Unfortunately, I don't have a suitable engine for this turbine yet. So for this first test, I am going to use compressed air. The plan is simple. I'll pump up about 1.5 bar in a tank, then release that pressure suddenly onto the turbine wheel. Three, two, one. I got around 112,000 RPM. Let me try adjusting the nozzle gap. During the test, the nozzle rotated and jammed the turbine. I need to make a lock nut. The lock nuts are made, the nozzle is fixed in place. I'll try installing a pressure gauge to see whether the turbine creates any pressure at all. I know this isn't really correct, since the air is pushing straight into the gauge with nowhere else to go. In reality, it should be flowing into the engine, but to be honest, that doesn't matter to me right now. Hopefully you caught that. The turbocharger produced 0.1 bar of pressure at around 130,000 RPM. Whether that's cool or not, I'll let you decide. I do have an engine I can mount this turbine on, but it's about 10 times smaller than what this turbo actually needs. Still, I decided to try it just for fun. For that, I need to make an exhaust manifold. The aluminium one came out bad. I'm making a new one from brass. I'll have to use some very expensive solder for this. Well, the result was expected. You saw the numbers. The turbocharger showed only 14,000 RPM. Like I said, the engine is way too small for this. And then an idea hit me. I decided to remove everything from the engine that was holding it back from reaching maximum RPM. That way, my homemade engine might actually fly apart, and you'd get some great content out of it. But without any mufflers, it got really loud, and honestly, I got scared. Let's take a look at that. Maybe we'll save the destruction for the next time.